0.00007. They're like, I must have done something really wrong.
Yep. If you can anchor them to 50%, Mr. Welsh makes a great point, and figure out where this is compared to 50%, well, I can pretty easily in my head say 50% or half of 50 is 25, and that should tell me, should my answer be above or below that 50% mark? Should it be close to? Should it be really small compared to it? All of that. Good. What about the second one, Ella?
0.04 times 78 equals 3.12.
Do we agree? That is correct. 0.04 times 78 equals 3.12. Weston. We aren't doing that one right now. Okay? All right, so here's what we're doing today. We're going to spend the first kind of half of our block doing some new stuff and looking at some word problems and something called the percent proportion, which we're going to use. We'll take a break since it's a block day, and then we're going to spend the second half working on these task cards. Okay? These are not the easiest problems that you're going to do. You're going to have to put some thought into them, and I'm going to be honest, it's just not the easiest work that we've done this year. But you're going to have plenty of opportunities to ask questions and to get help and all of that. Ella.
Are we playing a review game?
Tomorrow, we are going to play a review game. Yep. So tomorrow's class period, the whole class period, we're going to spend working on a review game. And my plan for the review game is to take your summative section by section and turn it into a review game. So essentially, like, picture if I had a retake version of this test, I'm turning that into a review game. So you will see section by section by section what's going to show up on your test Friday. So there shouldn't be really many surprises. And we'll do that as a practice tomorrow in class. Blake. It's going to be a surprise. It's one we haven't played this year. Some people find it a bit unfair, but I tend to like it. So we'll see. We'll see what you think. I don't know. I guess we'll find out tomorrow. Oh my gosh, wouldn't that be fun if I was always the winner?
No.
Yay. Okay, so anyways, that's tomorrow, and then summative on Friday. So that's where we're headed, okay? You need your notebook, you need a pencil, you need a calculator out in front of you. Before we get into a new stuff today, I have a challenge problem for you to work on with your table group. So you're going to talk to the people at your table. And I went and did a little shopping at Old Navy. And, you'll probably appreciate this more when you're an adult, but sometimes you find like a really great shirt and you find that they sell it in like a variety of colors, but you're like, man, this is like the most comfortable shirt and I love it, that you buy it in like all the different colors that it's come in. So I bought 3 of these plaid shirts that were $32.99. And then I was like, man, I really need to change my wardrobe a little bit. So I found these Rockstar jeans, because obviously I'm going to be a rock star pretty soon. So I needed the Rockstar jeans to go with it. So I got 2 pairs of those that were $24.97 each. And then this blue shirt, I was like, that seems like a shirt that you would go meet somebody important in. And so I bought it so that I've got an outfit to meet Justin in. So I bought those 6 items, and they were taxed at 7.5% sales tax. I would like you to work with your table groups. I'm going to give you a couple minutes here to see if you can come up with my final bill at Old Navy. What did all of this cost me altogether? I'll give you a hint. Some people ask, well, do we do tax on each thing individually and then add it all together? You could, but when you go shopping, typically what happens is all of your things get rung up, and you get what's called a subtotal, which is like the total of everything before tax, and then you can just find the tax on that subtotal amount. Okay, so instead of finding the tax on each individual item and then trying to combine it all, get your subtotal, what it costs before tax, tax it, and then get me a total cost. So work with your table groups. Your final answer should be between $150 and $200 if you do this correctly. And I'll give you a couple minutes.
Probably this very similar on your study.
Here we go. So the first thing, we were looking for a subtotal. So first thing I needed to do, if I got 3 of these plaid shirts, we're done talking and we're going through this together. If I got 3 of these plaid shirts for $32.99, I needed to figure out a cost of those 3 plaid shirts. What did they cost? Cecilia. 98.97, and you got that by multiplying 3 times 32.99, correct? Okay, good. Then I got 2 pairs of Rockstar jeans for $24.97 each. What was that cost? Anaya? $49.94. And then I got this one blue shirt for $19.99. What do I need to do with those 3 numbers now? Bless you. Miriam?
You have to add them together.
Good. So we're going to add up 98.97 plus 49.94 plus 19.99. And that's what's going to give us what's called our subtotal. What was that subtotal amount, Gus?
The subtotal is $168.09.
Like that?
No, 90.
It should have been 168.9. We can't add that 0 in the middle. We have to add it at the end. So it should be 90 cents because it was 0.990. Okay, 168.90. So this is what's called our subtotal. That's the cost of all of those items together before tax. Now we've got to get this tax amount. What do we need to do with the 7.5% sales tax? What are we going to do there? Anaya?
Turn it into a decimal.
Good. Which is? 0.075, and we are going to multiply. Got a lot of people telling me to divide. We haven't divided anything, you guys. We're not dividing. So we're multiplying. When you do that, what did you get for your tax amount? It should be 12 something. Weston?
All right. 180. Oh, it was $12.67.
$12.67? And so that's my tax. What do I need to do for my final step? This is a big problem. Final step, tax and subtotal. What do I do with those 2 things? Elliot?
You add them together.
Good. So we're going to go back and add the 168.90 to the 12.67 for a whopping total of $181.57. Should have been the correct answer. Anyone get there? This one was tricky. Lots and lots of work for this. Good. Nice job. As we're learning our new percent proportion stuff today, I would find a spot in your math notebook where you've got your notes on percents and stuff just to jot down. I don't have an official notes page for you, but something that you can jot down your just some of the examples we do today, so you've got something to look back at. Okay? All right, here we go. This is the last new thing that's going to be on your test on Friday. Today's Wednesday, you're right, yes. We're going to do some practice with it today, and then you're going to have some opportunities to apply it in those task cards here in a little bit, okay? So basically what we're looking at today, and this is why I have this problem written on the board, all the problems that we've done with finding percents of numbers so far have been problems like this. Finding 45% of 180. So we're finding a percentage of a whole amount. Okay, if 180 is my whole, I want 45% of that, which is a portion of it, and I want to know what that portion is. What we're going to shift gears on today is using what we call this percent proportion to figure out, well, what happens if instead of me giving you the whole, I'm telling you what that percent is equivalent to, and you've got to tell me what the whole amount is. So you're finding a different piece of essentially this phrase. So an example like that would be 28 is 40% of what number? Or 40% of what whole number is 28? So I could write that out as 40% of what is 28 is essentially what we're looking for. So you can see I'm finding a different part here. Okay, in order to do that, we're going to use a percent proportion, and this proportion is what I want you to have written down for sure in your notebook. Okay, the proportion, we're going to come back, actually no, is what we're looking at is we're looking at putting the part over the whole and setting that equal to the percent over 100, because percents are always out of 100. So find somewhere to write that down. And then in parentheses, next to part and whole, oopsies, Next to part, you're going to write the word is, and next to whole, you're going to write the word of. Now, that probably doesn't make sense right now, but I'm going to give you a second to write it down, and then we're going to talk through and look at some example problems here. So you're writing this proportion down as your example. Bless you. If you want an example of what this looks like, you can write down this phrase, and then we're going to show you the proportion here. So basically, what you need to stop and think about, and this is what's going to be the tricky part, is what information do I have? Do I have the part? Do I have the whole? Do I have the percent? 100 is always going to be 100 because our percents are always going to be out of 100%. Okay, so the easiest part to come up with first is if it says 40%, that literally has a percent sign attached to it. So we know we're going to be putting 40 over 100 because my percent always goes over 100. Okay, the other part is a little bit trickier. Is this 28 the part or the whole? And in problems like this where it says of what number is 48, there's those two words that I had you write down in the parentheses. Is, the word that's with the is the part, and the word that, or the number that's with the of is the whole. So 40% of essentially what whole number is 28. So we're going to put 28 on top with the part and put the whole as my variable. I'm solving for that whole amount. So again, 40% of what whole number is equivalent to 28. Now we have a proportion set up. Luckily for us, for the past two topics, we've solved proportions. So this step shouldn't be new. What would we do to solve this? Gus?
So you go off to the side, you put on one side, preferably the left side, you put 40x, and then you circle the 28 and the 100, and then you put 28 times 100.
Yeah, we're going to use cross products to solve these. So we're going to have 40x equals 28 times 100, which is 2800. And then we're going to divide by 40. And we end up with x equals 70. So basically what that's telling us is that 28 out of 70 as the whole is the same thing as 40%. Or 40% of, better, 40% of 70 is equal to 28, is what we just solved for, okay? If you memorize the proportion, it's easy enough to plug things in. The hard piece of this is going to be figuring out where do I plug those different numbers in? Do I find the part? Do I find the whole? Okay, what's even trickier is these problems that we've been solving, 45% of 80. So our tax, our tip, our discount problems. We can solve all of those problems using the percent proportion, but the way we've been doing it is kind of like a shortcut. Okay, so if you're having a hard time, I guess let's say, if you're having a hard time looking at the problems, the different problems, and you're going, oh my gosh, do I use the proportion for this? Do I turn the percent into a decimal and multiply? Do I do this? Do I do that? Okay, the one method that will work for every single problem is using this percent proportion. So if you're trying to figure out like, I don't know if I turn it into a decimal, I don't know what to do, then just use this proportion for all of them and it's going to get you the right answer as long as you plug things in the right spot. Okay, so let's take a look at some examples. We're going to skip over these. Okay, I'm going to change this first one though because I realized in the first class that I really goofed on my numbers. All right, let's make this a 30 instead. Okay, all right, so let's see if we can set up a proportion for this first one. 15% of blank equals 30. Think back to when we talked about buzzwords for equals. What was a buzzword that might help us for equals, Blake? Yeah, so thinking of that as is 15% of what is 30, okay? I like to start with my percent, and if I know the percent, sticking that over 100 because that's the easiest part to find. So what number, or should I be using a variable for this first one, is the percent? Jonah? Yeah, 15%. So we're going to have 15 over 100. And then is that 30 the part or the whole? The is or the of? Should it go on top or bottom? 15% of what is 30? Part or whole?
Part.
Oh, I'm hearing both. How many people think it's the part? How many people think it's the whole? Oh, some of us didn't have an opinion. It is the part. Because we're trying to figure out 15% of what whole number, what whole amount is equal to 30%.
Buzzwords.
Yes. All right, so then we would solve this one. We would have 15x, and we're not going to solve all of these because I know you've done cross products a million times, and that's not what our focus is going to be. But for this one, we would do 15x equals 30 times 1,000. I would divide here, and I should get x equals 200. So basically that's saying 15% of 200 is 30. And if you plug that back in at the end, you should be able to fairly quickly do an estimate and see if that makes sense. Does it seem like 15% of 200 is about 30? That feels pretty good. If I didn't do this, right, and I set it up the opposite way, hang on. If I had flipped those numbers, I would have gotten 4.5. Does it make sense that 15% of 4.5 is 30? Can 15% of 4.5 be a number bigger than 4.5? No. So that would be one that if I set that up the wrong way and I flipped where my 30 and my x were and I solved and I got 4.5, I should probably stop and be like, hang on. If I plug that back in, that doesn't make sense. 15% of 4.5 can't be 30. So you can always go back and just ask yourself, does my answer make sense or not? Okay. What about the next one? Blank percent of 170 equals 246.5. Start with your percent over 100. Do we have the percent?
No.
No, so that's where our variable is going to be. We've got to figure out of 170 is 246.5. What's the part? What's the whole? Don't be fooled by this one. Gus?
The whole is 170 and the part is 170 and the whole is 246.5. Oh,
No, you were right to start with.
I was right.
That doesn't feel good, right?
No, it doesn't.
Why do I have a number that's bigger on top? That doesn't feel right, which is why you stopped and changed your mind. But you were right. Okay,
It's over 100%.
we should get an answer over 100%. Yes. Okay, it's okay to get percents that are bigger than 100%. That's real life. There are things that are more than 100%. So you were right. What percent of 170 the whole is 246.5? That's our part. So that's our setup. We're not going to solve this one. We're just going to practice setting them up so that we can kind of move through more examples. Okay, let's look at one more example. 160% of blank equals 128. Start with your percent over 100. Do we have the percent?
Yes.
What is it?
160.
So here's another example. If we've got a percent higher than 100%, that's fine. We're going to leave it like that. And then that 128, is that my part or my whole? 160% of what equals 128? Cami? Perfect. It's the part. So that's going to go up top, and my x is going to go on the bottom. Good. Okay. On this next slide, I'm going to circle, actually I'm just going to cross out ones I don't want you to do. I'm going to have you set up, not solve, just set up like this. Plug the numbers into the proportion for 6 different ones for practice. You can talk to the people at your table group for this and compare, and then we'll go over answers here in a couple minutes, okay? Nope. Do not need to get answers for any of these. You're just setting up a proportion. So you're going to do 1, 3, 5, 7, 8, and 9. Okay, so you're doing the 6 that are not crossed off. Just set up a proportion. We'll go over answers here in about 3 or 4 minutes. Ready, set, go. All right, let's start with the first one. What'd you get for the very first one? Blank percent of 190 equals 133. Jonah?
133 over 190 equals x over 100.
Perfect. Now, what I should have said earlier, I forgot. This question came up first period, and it was a great question. Somebody said, can I flip where I've got these? Meaning, can I write it as x over 100 equals 133 over 190? And put the side that has the percent on it first? You can. It doesn't matter which one comes on the left and which one comes on the right. What matters is the top and the bottom. I can't flip my top and my bottom because then I'm flipping my part and my whole. But side to side, that's okay. Okay. Cam, you want to take the next one? Good. 81 over 90 equals x over 100, or x over 100 equals 81 over 90. Perfect. What about number 5? I'm going to jump to the left-hand side where there's more space. Miriam?
I put 95 over 100 on the left side.
195?
Yeah.
Okay.
And on the right side, I put 19.5 over x.
Perfect. Same thing. Could have flipped that. You could have had 19.5 over x equals 195 over 100. Both of those would work. Nice job.
Yeah, that's the second one you did is what I did.
Oh, you did this one?
Yeah.
Okay. Sorry, I flipped your left and your right. All right, 7, 165% of 60 equals what, Maeve? Yep. Perfect. X over 60 equals 165 over 100. Gus, take the next one for us.
I put 204 over x equals 170 over 100.
Beautiful. And one more. Let's go for the 6th one. Blake, what'd you come up with?
X over 200 equals 125 over 100.
Perfect. Nicely done. 6 for 6 on that.
Why'd you cross out some of it?
Just so it was fewer for you to have to do. I picked 2 of each kind for you to do, just as a quick practice, because I really want to shift. So here's the issue. You're not going to see a lot of problems set up like this. Where it's going to show up is more in context, so in the word problem piece. So I want to shift to, can we set them up for word problems? So we're going to do just a few word problems for a couple more minutes, and then we'll take a break and come back and kind of pick up from there, okay? So let's look at 2 word problems here that are similar to what we just talked about. It says, in one community, 84% of the animal shelters microchip cats and dogs before adoption. If you don't know what that term microchip means, basically it means that they insert, it's literally like a little chip. They take it and like shoot it in a shot underneath your dog or cat's skin. The purpose of a microchip is if your pet runs away or gets lost, if somebody finds them and takes them to a vet, they can scan them for this chip, and that chip will pop up on the like on the vet's computer and say, oh, this is Mrs. Wainscott's pet and her phone number is blah, 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 blah. Like it's linked to you so they could call you and say, hey, somebody found your dog and get it back to you. Huh? Kind of like an air tag for a dog or a cat, except much smaller, and it just gets put into them. Anyways, so that's what that means. So 84% of animal shelters microchip them before adoption. If 21 shelters in the community microchip cats and dogs, then how many animal shelters are in that community? So here's where it gets tricky. Now I don't have is or of, and it doesn't say part or whole, and I've got to figure out what do I know and where do these things go. So my number one piece of advice is to always start by looking for your percent and putting it over 100. Do I have a percent for this one?
Yes. Absolutely.
What? 84. So that's going to be one side right off the bat. That's easy to figure out. My other part, it says if 21 shelters in the community microchip, how many animal shelters are in that community? So I've really got to stop and ask myself, is the 21 the part of the shelters or is it the whole animal shelters? It's the part. So I'm going to put that on top, and I'm searching for or solving for how many total animal shelters. I would set that up. I would use cross products. I would solve it. For time's sake, just so that we can get up and moving sooner, we're not going to use cross products and solve right now. We're just going to focus on the setup, okay? All right, try this next one at your seat. We'll go over it in a minute. It says during 1 year, 60% of the hurricanes that struck the U.S. were Category 1 hurricanes. If 9 Category 1 hurricanes struck the U.S. that year, What is the total number of hurricanes that struck the U.S. that year? So 60% are Category 1. There were 9 Category 1 hurricanes. So what was the total number that struck the U.S.? Just get me a setup here. Start with your percent is my advice to you. Then think, is that part? Is that whole? Where do I put those numbers? Who feels like you might have a good setup for this one? Chase.
60 over 100 for that side.
Perfect. Beautiful. Yep, 9 is the part. And look at this. What was the total number? What's the key word there? Total. That helps us figure out, oh, we're looking for the whole here. It's asking for the total. So sometimes you'll get little clues in the word problem that will help you figure out where that goes. Miriam.
So you know how we're not solving them like right now?
Yep.
Do we have to solve them in the test?
Yeah, you'll solve them on the test. The solving, though, is cross products, which we've done for the last 2 summatives. So for time's sake, the new piece that I really want you to focus on right now is the setup. So that's why we're just tuned into the setup. All right, we're going to do 2 more slides, I think, and then we'll take a break. In Mrs. Wainscott's class, 18 out of 22 students turned in their homework on time. What percent of the class turned in their homework on time? Ooh, what do you think the setup should be here? 18 out of 22 turned it in on time. What percent?
It would be 22 because the whole. Wait, 22.
What goes over 100?
22.
X. What percent? We don't have the percent this time, so our variable is going to be on top of the percent. Cammie, what's the other side?
18 over 22.
Yep, 18 out of 22. 18 is the part, 22 is the whole. Beautiful.
It even says like
18 out of 22 students. Okay, this next one's a little bit tricky if we don't pay attention to the language. It says for every $10 that Owen earns, his parents require him to save $2. So he's saving 2 out of $10. What percent of his money does he get to spend? What goes over 100? Start there. What goes over 100? What's the percent? X. What's going to be our other side? This one's a little bit trickier. He saves $2 out of 10. What does he get to spend? Weston?
He gets to spend $8.
So he gets to spend 8. Does that 8 go as the part or the... Perfect. And what's our whole?
10 days.
Yes, good. So that one's tricky because it talks about saving and spending, and it's kind of like that proportions work we did. Okay. Ooh, we got to make sure that we're putting things that match up labels-wise there. Okay. Good. Last slide. This top one says a 20% off sale is going on, making a pair of jeans $9.60 cheaper. What was the full price of the jeans? So we've done discount problems, except we found the discount amount. Now I'm giving you the discount amount, and you've got to tell me what was the original price. What would a setup for this one look like? What would the setup for this one look like? Gus?
you put 20 over 100.
Great start.
And then it would be equal to $9.60 over X.
Yep, so that's the part. We want to know what was that original whole amount. Beautiful.
What was the full price?
The full price, the total price. Good. All right, we're going to pause there. I'm going to give you a 5-minute break. We're not going to do this bottom problem. I don't like it. So it is time to let you know. No, we already know that I'm going to tour with Justin soon. He sells 16% of his tickets as reserved seats. So there should be enough seats for me to invite all my friends and family to reserve seating. I guess we'll see. We'll have to see how many of this is. 16% of his tickets are reserve seats at an upcoming concert. There are 8,000 tickets, a nice, small, intimate venue for my debut with Justin. 8,000 seats. How many tickets are reserved? What would your setup for this one look like? Cammie? Good start. 16 over 100 because that's our percent. What are you putting on your other side? Perfect. X over 8,000 is on your other side. Beautiful. Let's solve this one just to see how many tickets are going to be reserved. 100x equals 16 times 8,000. What is that? 12800. Somebody plug that in? Yeah. Divided by 100. X equals 1,280 tickets are reserved.
Are reserved.
I don't know if that's going to be enough for all my friends.
Yes,
How many
for all
fans do
your
you have?
friends.
No. 1,280.
180 per square foot feels left out.
Yeah, that'd be sad.
Honestly,
All right,
I ain't going.
we're going to do one more problem, and this one looks a lot like a problem on your study guide.
Yippee!
So I'm going to give you a hint as to how to solve problems like this, and then you're going to see one or two like this on the task cards as well. So it says, in the school parking lot, there are 60 cars. Of those cars, 30% are blue, 15 were black, and the rest were tan. What percent of the cars were tan? Here's what makes this problem a little bit trickier. We got 3 different types of cars. It gives us a percentage for one. It gives us a number of cars for the other one, and then we have to solve for the third. So the first place you want to start to figure out, should I be finding percents or should I be figuring out how many cars, is look at the question. What is the question asking us here? Gus,
What percent of cars are tan?
what percent of cars are tan? Which means I want to turn all of these into percents. So I like to write out what I know. Well, I've got blue cars, and that one's already given in percent form. So I'm actually not going to do anything with that because I already have a percent there. Okay. What I need to work on next, though, is my black cars. My black cars are not in percent form, but I can find the percent that are black. What would I set up to figure out how many cars, or sorry, what percent of cars are black, Maeve? Anyone? What percent are black? What could I set up? Do I have the percent for black cars? What should be on the other side? Over. Yeah, 15 is the part that are black, 60 is the whole, the total number of cars in the parking lot. I could solve proportions here. Again, here's another shortcut. Just like there's a shortcut for this problem, turn your percent into a decimal and multiply. If I'm trying to figure out what the percent is here, you've been doing that all year on your tests. So you could use cross products here, or how do I turn that fraction into a percent, Blake? Yeah, divide and multiply by 100. 15 divided by 60 times 100. What percent is that? 25%. Good. Okay, so now I know 30% are blue, 25% are black, the rest are tan. What do I know about percents? They add up to 100. So what percent is already accounted for here? Weston.
55, which means if the answer is 45.
So if it's all out of 100%, and I used 55% for black and blue, 45, not cars, 45% are tan cars. It's a lot of tan cars. Okay, questions on that? Gus?
If you're trying to do a decimal, would you turn 30% into blue and just add it up?
If you're trying to get a number, yeah. So if it said how many cars are tan, we would have done this differently. We would have left the black as 15 cars, and then we would have figured out how many cars is 30% of the 60, and then subtracted from 60.
30% of 60.
Correct. And then subtracted both of those amounts from 60.
And then
Yep. Good question. All right, these task cards, here's what I'm going to tell you. I think it would be really helpful for you to be working with somebody and going around and solving these with somebody. There are 16 task cards. They all have a letter in the top left corner. You can start on any of them. When you solve them, they are self-checking in the sense that if I get an answer to this and my answer is 50, I should be able to find 50 in the right-hand corner of one of the other task cards. If I don't see that number, my answer is not correct, okay? You've got the rest of class to work on these, so it's just over a half an hour. I'm going to be posting these task cards and the answer keys to Schoology, so if you don't finish them, but you'd like to keep working on some for extra practice at home, you will have access to all of this at home too, okay? So give me a second to get your recording sheet passed out, and then you'll get to work.